The Sun is much more than a star. It is the beating heart of the solar system, the invisible force that shaped every planet, every moon, and every fragment of rock that orbits around it. When we look at it, we see only a sphere of intense light in the sky. But what we are really witnessing is a cosmic reactor, a nuclear furnace that, for billions of years, has been transforming hydrogen into helium, sustaining the warmth, the climate, and the very existence of life on Earth. No star lives forever, and the Sun too moves toward its end, silent and inevitable, just like everything else in the universe. About 4.5 billion years ago, the immensity of space was nothing but scattered dust and gas. In one region of the galaxy, an interstellar cloud began to collapse under its own weight, compressed by gravity and perhaps by the distant explosion of a supernova. At the heart of that collapse, the Sun was born. Its formation was the inaugural act of the solar system. When the temperature and pressure became intense enough, hydrogen nuclei began to fuse, releasing energy. At that moment, the Sun ignited. It was a new star, a young and vibrant flame that would soon dominate everything around it. Around that newborn Sun, a disk of dust and particles took shape. From it, the planets, asteroids, and moons were born. Everything that exists today, from the mountains of Earth to the rings of Saturn, is the result of that same birth. Every grain of dust, every molecule, was rearranged by the Sun's energy. It became the center of a system that has been turning in harmony for billions of years, and yet every second of its existence is a battle between opposing forces. Gravity tries to make the Sun collapse upon itself, while the energy from nuclear reactions pushes outward. That perfect balance is what keeps it alive. Throughout all this time, the Sun has shone with constancy, radiating heat and light that travel about 150 million kilometers before reaching Earth. This energy powers photosynthesis, ocean currents, winds, and all the biological cycles we know. If the Sun were to vanish, the planet's temperature would plummet to lethal levels within days, and life would disappear within weeks. Humanity owes everything to the balance of this star: the climate, agriculture, oxygen, and even the possibility of dreaming beneath the sky illuminated by it. Yet, as majestic as it seems, the Sun is only one among hundreds of billions of stars in the Milky Way. It holds an ordinary position, not too hot, not too cold, not too large, not too small, and it is precisely this moderation that made life as we know it possible. Still, even a stable star like the Sun carries within itself the seed of destruction. Every second it consumes millions of tons of nuclear fuel. One day, that fuel will run out, and when that happens, all the stability we know will collapse. The Sun will grow, change color, expand until it engulfs entire worlds, and the solar system it once created will fall apart. For now, however, it remains there, shining with the same calm it has shown for ages. It is strange to think that every sunrise on Earth is a reminder of the time left before the end. The Sun is both the symbol of life and the omen of cosmic death. It was born from collapse and will die in expansion. Like us, it is made of beginnings and endings, of cycles and transformations. The story of the Sun is the story of existence itself. And to understand how it dies is also to understand how everything in the universe follows the same path. From creation to dissolution, from light to silence. Everything began in silence. There was no sun, no planets, not even the concept of light. What existed was only an immense cloud of gas and dust scattered through interstellar space. This cloud, formed mainly of hydrogen and helium, the simplest and most abundant elements in the cosmos, drifted inertly until gravity began to act. Grain by grain, particle by particle, everything started to attract itself slowly, as if the void had decided to breathe. The compression of matter generated heat, and what had been only darkness began to shine. It was the birth of a star. The process is called gravitational collapse, and it is the first step in the life of any star. When a dense region of a molecular cloud becomes unstable, gravity overcomes internal pressure and makes everything fall toward the center. That matter accumulates, forming an increasingly hot sphere. As the temperature rises, hydrogen atoms collide with greater force until nuclear fusion occurs, the moment when hydrogen transforms into helium, releasing energy in colossal proportions. When this happens, the star awakens. It is the ignition point of the Sun, the instant when the emptiness of space gained light. At this early stage, the sun was young and violent. It released jets of plasma, intense winds, and powerful radiation, shaping the environment around it. In the disk of dust and gas that surrounded it, particles began to collide and clump together. These collisions gave rise to the first solid bodies, which would later become the planets. Earth was born from this dust. Mars, Venus, Jupiter, and all the other worlds of the solar system are, in essence, children of the sun, fragments of the same material that once condensed within its core. Each planet carries in its composition the signature of solar birth. The young sun rotated faster than it does today. Its energy was unstable, and its magnetic fields intertwined in constant explosions. This turbulent phase lasted for millions of years, until the balance between gravitational force and the pressure of fusion was established. From that moment on, the sun entered the phase that astronomers call the main sequence, a long period of stability that continues to this day. It is in this phase that a star shines steadily, sustained by the equilibrium between gravitational collapse and the expansive force of nuclear energy in its core. When we look at the sun today, it is almost impossible to imagine that it was once an unstable ball of fire surrounded by cosmic debris. Everything that now seems solid and permanent was born from initial chaos. The mountains of Earth, the rings of Saturn, and even the frozen comets at the edges of the solar system are witnesses to this process. The dust that formed the planets also contains the elements that make up life: carbon, oxygen, nitrogen, and iron, created in previous generations of stars that died before the birth of the sun. This means that our sun is the heir of stars that came before it, and one day, its own death will nourish the birth of others. This is one of the deepest truths of the universe. Nothing is lost, everything transforms. The energy that once warmed the hearts of ancient stars now pulses within the sun. And the same energy that the sun emits today will, in the future, be the seed of new stars and worlds. The story of the sun is an eternal cycle of death and rebirth, of destruction and creation. Every ray of light that reaches Earth carries within it the memory of stars that vanished billions of years ago. When the sun was born, it merely continued a cycle that never had a beginning and will never have an end. At the center of the sun lies a secret that sustains all life in the solar system. It is a region of energy and pressure so intense that it defies human imagination. There, matter behaves unlike anything we know. The heat is so extreme that atoms are torn apart, leaving nuclei and electrons free. In this environment, nuclear fusion takes place, and from it, light is born. It is in the heart of the sun that hydrogen, the simplest element in the universe, transforms into helium, releasing a colossal amount of energy every second. This energy is the reason the sun shines, warms, and gives life. The temperature in the sun's core exceeds 15 million degrees Celsius. The pressure is so high that hydrogen nuclei, which normally repel each other, are able to fuse. This fusion is the process that transforms mass into energy, following the famous relation described by Albert Einstein, which states that a small amount of matter can generate an immense quantity of energy. Every second, the sun converts about 4 million tons of its own mass into light and heat. It is a constant and silent consumption, like a cosmic breath that maintains the balance of everything that exists around it. This energy does not reach the surface instantly. It is born in the core and takes thousands, sometimes millions of years, to pass through the inner layers of the star. First, it travels through the radiative zone, where photons, particles of light, are continuously absorbed and re-emitted in random directions. This chaotic journey makes energy move extremely slowly, as if each ray of light were trapped in a labyrinth of incandescent matter. Then it reaches the convective zone, where hot plasma rises, cools, and sinks in a constant cycle, similar to the motion of boiling water in a pot. Only then does the energy reach the visible surface of the sun, the photosphere, from which it spreads through space. From the photosphere, light travels approximately 8 minutes before reaching Earth. What warms us today is the result of nuclear reactions that occurred thousands of years ago inside the sun. Every sunrise we witness is, in truth, the past of the star that sustains us. That light carries the story of matter, the memory of fusion, and the force that keeps planetary orbits stable. It is because of this balance between gravity and radiation that the sun neither collapses nor explodes. Gravity tries to compress the star, while the energy from fusion pushes everything outward. This constant struggle between opposing forces is the secret of its stability. The structure of the Sun is composed of distinct layers, each with a fundamental role. The core is the central reactor. The radiative zone is the diffuse barrier that traps and redistributes energy. The convective zone is the boiling layer that carries heat to the surface. Above it, the photosphere is the luminous face we see in the sky. Beyond that lie the chromosphere and the solar corona, the immense aura of plasma that stretches for millions of kilometers. This corona is visible only during eclipses and reaches temperatures even higher than the surface itself. The exact reason for this remains one of the greatest mysteries of modern astrophysics. Throughout this chain of processes, the Sun maintains itself in an almost perfect state of harmony. It is a balance so delicate that a small variation in energy production could alter the climate of the entire solar system. This stability is what makes Earth's existence possible as we know it. Nuclear fusion in the heart of the Sun is the invisible foundation of every breath, every ocean wave, every form of life. Everything that grows, moves, and flourishes on this planet does so under the same principle, the relentless conversion of matter into energy. As long as the Sun continues fusing hydrogen into helium, it will remain alive, a heart that pulses light in the middle of the void. But this balance will not last forever. Every second, the Sun consumes itself. Its reservoir of hydrogen slowly diminishes, and over billions of years it will transform. When its fuel runs out, the core will collapse, and the star will change in form, color, and size. What is now stability will become chaos. The nuclear fusion that now generates light will also mark the beginning of its death. The Sun, which gives life to all, will one day be the cause of the extinction of everything that depends on it. The Sun now lives its phase of maturity. It is in perfect balance, at the height of the stability of its existence. Every particle within it remains in harmony between the gravity that tries to compress it and the expansive force of nuclear fusion that pushes outward. This equilibrium keeps it the same size, brightness, and temperature for billions of years. Astronomers call this stage the main sequence, the long period in which a star steadily burns hydrogen in its core, maintaining itself without growing or shrinking. The Sun is precisely in this phase, and that is why its light shines with such constancy in the sky. On average, the Sun converts about 4 million tons of mass into energy every second. This energy radiates in all directions, keeping the solar system bound around it. The temperature of its surface is about 5,500 degrees Celsius, while the core surpasses 15 million. The solar magnetic field, in turn, is one of the most complex forces in the solar system. It twists and deforms with the star's rotation, giving rise to sunspots, flares, and coronal mass ejections, phenomena that can directly affect space weather and even interfere with satellites and power grids on Earth. These sunspots are cooler regions on the surface, where the magnetic field is intense and the convection of plasma is interrupted. They follow a cycle of approximately 11 years, alternating between periods of high and low activity. During solar maximum, there are more spots, more storms, and greater radiation output. During solar minimum, the Sun appears calmer. This cycle is natural and has occurred for millions of years, slightly influencing Earth's climate and even some atmospheric patterns. It is a reminder that even in equilibrium, the Sun remains in constant internal motion. On the human scale, it seems immutable. The same Sun that warmed the dinosaurs hundreds of millions of years ago is the one that shines upon us today. But in astronomical terms, the Sun is slowly changing. Its luminosity increases by about 10% every billion years. This means that, in a distant future, the heat it emits will be strong enough to alter Earth's climate, evaporate the oceans, and render the planet uninhabitable. This transformation is inevitable and silent. No living being will perceive the exact moment when balance begins to break, but it will come. Even so, life in the solar system remains dependent on this star. All winds, currents, ecosystems, and weather cycles on Earth exist because of the Sun. The energy that reaches the planet's surface powers photosynthesis, moves the air, and creates the temperature differences that shape weather and seasons. Sunlight is the invisible thread that connects the ocean to the desert, the forest to the atmosphere. Every form of life is an extension of the energy that flows from the Sun, transformed into heat, nourishment, and movement. Science watches the sun constantly. Specialized satellites study its flares and measure its brightness. Every variation, no matter how small, is recorded. With this, astronomers can predict its future with relative accuracy. We know the sun is approximately halfway through its life. It has already consumed much of the hydrogen in its core and will remain stable for about another 5 billion years. After that, it will enter a new phase, beginning to expand until it becomes a red giant. At that moment, the equilibrium that sustains everything today will be broken, but for now, the sun remains calm. Each morning, it rises with the same light that illuminated the dawn of Earth's history. This stability is in itself a kind of cosmic miracle. Everything that depends on it, from forests to seas, exists in a balance as delicate as that of the star itself. Life is a reflection of solar harmony. As long as the sun continues fusing hydrogen, Earth will keep turning beneath its light. But one day, inevitably, this harmony will fade. The current calm is only a pause in the slow march of stellar time. And when the sun begins to change, it will mark the beginning of the end, the omen of the transformation to come. The sun, which today seems eternal, has already silently entered the second half of its life. The balance that keeps it stable is not permanent. The nuclear fusion in its core constantly transforms hydrogen into helium, and every second a portion of that primordial fuel disappears forever. Over the course of billions of years, the hydrogen at its center will run out, and when that happens, the sun will begin to change. What is now stability will become imbalance, and what was once light and controlled warmth will turn into chaotic force. The end will not come as a sudden explosion, but as a slow and inevitable transformation. As the hydrogen in the core is consumed, the balance between pressure and gravity breaks. Without fuel to sustain fusion at its center, the core begins to shrink under its own weight. This collapse increases internal density and temperature, compressing the helium that has accumulated in the heart of the star. At the same time, the outer layers start to expand, as the energy from fusion occurring in the regions surrounding the core is released unevenly. The result is a larger, brighter, and less stable sun. It is the beginning of the metamorphosis that will turn it into a red giant. With this expansion, the sun's brightness will increase dozens of times. Its color will gradually shift from yellow to orange, and then to deep red. The diameter of the star may reach such vast dimensions that it will engulf the orbit of Mercury, and possibly that of Venus as well. Earth, even if not completely swallowed, will be devastated by the heat. The oceans will evaporate, the mountains will melt, and the atmosphere will be hurled into space. The planet will become a carbonized desert, orbiting a sun that no longer sustains life, but instead announces its end. During this phase, the energy radiated by the sun will increase so dramatically that any trace of liquid water will cease to exist. Plants will die, the seas will boil, and in a short time, what remains of Earth will be an incandescent crust. The weakened magnetic field will no longer be able to protect the planet from solar radiation, and the surface will become a silent inferno. No form of life will survive. Even in the deepest layers underground, heat and radiation will penetrate to the point where nothing organic can endure. It will be the end of the biosphere, and with it, the end of everything humanity has ever left behind. But this apocalypse will not come violently like an explosion. It will be a process of slow transformation lasting millions of years. Gradually, the sun will become an aging star, pulsing in cycles of expansion and contraction. Each pulse will be an attempt at equilibrium, a struggle between the gravity that tries to compress the core and the energy that tries to escape. In this cosmic back and forth, the sun will grow increasingly unstable, shedding layers of matter into space and illuminating the solar system with a reddish, melancholic glow. This transition marks the end of the main phase of stellar life. It is the moment when the sun ceases to be a young star and enters cosmic old age. Hydrogen, its purest fuel, is exhausted, and helium, once merely a byproduct of fusion, begins to dominate the core. The sun starts fusing this helium into heavier elements, such as carbon and oxygen, through a process far more intense and violent. Each new fusion releases energy irregularly, making balance impossible. Thus is born the chaos that precedes the final collapse. Even when the sun appears at the height of its brilliance, it will only be the reflection of its decline. The star that once gave life to a blue and fertile world will become an immense and unstable flame, destroying everything it created. Yet paradoxically, this very process of death will also be a seed for the future. The material expelled by the sun will travel through space, enriching the interstellar medium with new elements. What now seems like the end is, on the cosmic scale, merely another step in creation. The sun will die, but the matter that composes it will continue to exist, scattered throughout the universe, ready to give birth to new stars, new worlds, and perhaps new forms of life. The sun is dying. Slowly, the balance that sustained it for billions of years is coming to an end. The core, compressed to extreme limits, becomes the incandescent heart of a colossal transformation. The outer layers, inflated by the energy released in the intermediate regions, expand like a mantle of fire into space. The star that was once a yellow, stable sphere begins to grow until it becomes a red giant, a vast, diffuse and pulsating star whose light will bathe the solar system in a deep and threatening glow. The color changes, the heat increases, and the sun transforms into a distorted and monumental version of itself. This expansion is slow but devastating. The solar radius will increase hundreds of times, reaching dimensions that defy imagination. Mercury will be engulfed first, disappearing inside the incandescent surface. Venus will not last much longer. Its crust will melt, its atmosphere will be stripped away, and the planet will become part of the star's body. Earth, which once orbited safely, will face an uncertain fate. Even if it is not completely swallowed, the heat will be so intense that it will vaporize the oceans and turn the surface into a desert of molten lava. The sky will turn red, and the horizon, dominated by a massive and distorted sun, will fill almost the entire field of view. As the sun grows, its density decreases. It becomes less compact but far brighter. Its energy is released chaotically in pulses of light and plasma. Immense magnetic currents intertwine and snap, producing explosions that hurl billions of tons of matter into space. These are coronal mass ejections, gigantic solar storms extending millions of kilometers. This intense activity sweeps through the solar system with waves of radiation, altering orbits and pushing asteroids and comets out of balance. What was once an ordered system becomes a maelstrom of fire and gravity. Inside the sun, the helium that accumulated throughout its life begins to fuse into carbon and oxygen. This new stage of nuclear fusion is violent and brief. Each reaction releases a tremendous amount of energy, making the sun pulse like an erratic heart. It expands and contracts repeatedly in a cycle lasting millions of years until the core can no longer support the outer layers. The star begins to lose mass, expelling its lighter parts into space. The result is a cosmic storm of incandescent dust, a wave of destruction sweeping across the nearby regions. The gas giants, distant enough to avoid destruction, will watch the spectacle from afar. Jupiter and Saturn will be illuminated by a light stronger than ever before. Their atmospheres will shimmer with red and golden tones, and their moons will become frozen deserts, bathed in a heat that arrives too late to bring life. The orbits of these giants will gradually expand, as the sun's loss of mass weakens its gravitational pull. The entire solar system will fall into disarray. Each planet will drift farther away, each satellite will lose stability, and what was once a perfect choreography will dissolve into dispersion. Meanwhile, Earth will be only a memory. Without oceans, atmosphere, or magnetic field, it will become a dark, lifeless rock with no internal motion. The planet's liquid iron core will solidify, and the world will die from the inside out. No trace of civilization will remain. Human ruins will dissolve in the heat, metals will melt, and rocks will turn to dust. Everything life ever built will vanish, and the sun, now a red giant, will be the luminous tomb of the world that once harbored life. Yet there is beauty in this end. The space around the sun will be illuminated by an immense nebula of orange and golden hues. This cloud of plasma and gas, formed from the remnants of the solar atmosphere, will extend for trillions of kilometers, reflecting the light of the dying star. For a time, the solar system will become a cathedral of fire and silence, a sublime vision of the end of an era. That fleeting beauty is the sun's final breath, the moment when it returns to the universe everything it once received: heat, light, and matter. From the death of a star is born the promise of new worlds. The sun, now a pulsating red giant, is about to lose what remains of its stability. Its outer layers expand and disperse into space, forming a bright, delicate veil around an ever smaller and hotter core. The solar system, which for billions of years revolved under the gravitational power of this star, begins slowly to unravel. Light still bathes the distant planets, but the balance has been lost. The sun's pull is no longer the same. It is becoming lighter, and its gravity, which once ruled all, starts to weaken. It is the twilight of the solar system, the end of its order, the beginning of its dispersion. With the loss of solar mass, the orbits of the planets expand. Jupiter, Saturn, Uranus, and Neptune begin to drift outward, moving into colder and darker regions. The moons that once orbited these gas giants firmly also feel the effects. Some escape into deep space, others collide, creating debris that will wander eternally. The asteroid belt is thrown into confusion, and comets that slept at the farthest edges of the solar system awaken, pushed by the sun's final winds. The cosmos becomes a stage of slow and chaotic motion, where what was once predictable turns into drifting uncertainty. Earth, if it still exists at this point, will be a cold, mute rock orbiting a deformed and weakened sun. Days and nights will no longer have meaning, for the light will no longer be constant. The planet will be battered by residual solar winds, and every particle on its surface will be eroded by radiation. No trace of its former atmosphere will remain. The mountains, turned to molten glass, will reflect a faint red light. The landscape will be a portrait of solitude. What was once blue and alive is now a petrified desert, spinning around a dying star. The outer planets will endure longer, but will also pay the price of gravitational decay. Saturn will lose its rings, dissolved into dust and carried away by cosmic winds. Its moons will drift away, becoming wandering bodies without fixed orbits. Jupiter, the giant that once shielded Earth by deflecting asteroids, will become a lonely planet, perhaps even ejected from the solar system, drifting through interstellar space as a cold, starless world. The order that once reigned will vanish completely. The solar system will cease to be a system, becoming nothing more than a dispersed collection of cosmic ruins. Among these ruins, fragments of ancient moons and asteroids will slowly collide, forming new rocks that perhaps in some unimaginable future may gather around another star. The destruction of the solar system is also the redistribution of matter. Nothing truly disappears. Everything the sun created will be scattered, diluted, and mixed into the interstellar medium, waiting for a new cycle of birth. The same material that once formed Earth may, in billions of years, become part of a new planet, in a new star, beneath a new sun. Meanwhile, the sun will continue to shed its final layers. Plasma drifts away in the form of luminous winds, creating a planetary nebula that will shine briefly, perhaps for a few thousand years, before fading completely. This will be the last beauty of the solar system, a vision that no human consciousness will ever witness, a colored cloud of light and dust floating slowly in space. At its center will remain what is left of the sun, a small, hot white point, the skeleton of a star. All that was once life, light, and warmth will be reduced to an incandescent heart the size of Earth. The reign of the sun will have ended. In the silence of this end, the solar system will cease to exist as we know it. No planet will remain bound to its original orbit. No orbit will be stable. Everything will be surrendered to emptiness, cold, and distance. What was once the home of civilizations, oceans, and forests will become interstellar dust drifting among the stars. And the sun, once the center of all life, will be only a fragment of light among trillions of other luminous points in the cosmos, indistinguishable, forgotten, silent. The twilight of the solar system will be the beginning of a night that will never end. The sun has reached the limit of its existence. After billions of years maintaining the balance between gravity and nuclear fusion, its fuel is gone. There is no more hydrogen to burn, and the helium that sustained its final flickers of energy has also been exhausted. The core collapses in on itself, compressed by its own gravity, while the lighter outer layers are expelled into space. What remains at the center is the naked heart of a dead star, a dense, incandescent, and silent sphere the size of Earth, but with nearly the mass of the sun. This is the birth of the white dwarf. A white dwarf is one of the most extreme states of matter in the universe. There is no nuclear fusion within it. The light it emits does not come from active reactions, but from the residual heat accumulated throughout the star's entire lifetime. Even so, its initial temperature exceeds 100,000 degrees Celsius. That energy is the sun's final breath, the echo of its former power. Inside the white dwarf, the atoms are crushed so tightly that the electrons are forced into close proximity, unable to be compressed any further. This phenomenon is known as degeneracy pressure, and it is what prevents the core from collapsing completely into a black hole. The density of this dead star is unimaginable. A single teaspoon of its matter would weigh tons. It is the cosmic corpse of the sun, a small, silent, and incredibly heavy body. Its light is faint yet pure, a bluish-white glow that spreads slowly through space, illuminating the remnants of the nebula that was once the solar system. This cold, steady luminosity will last for billions of years, gradually fading as the heat escapes into the void. The white dwarf is the final visible stage of the sun's life, a heart that continues to shine, even after it has stopped beating. Around it, little will remain. The ejected layers of the sun will continue to expand, dissolving into the interstellar medium. This cloud of gas and dust will carry the elements forged during the star's life: carbon, oxygen, iron, and silicon. Everything the sun created will be returned to the universe. This material will one day serve as the raw substance for new stars, planets, and perhaps new forms of life. The death of the sun, though it seems tragic, is merely part of the cosmic cycle. In the universe, every ending is a disguised beginning. Over the course of trillions of years, the white dwarf will continue to cool. Its light will dim until, in an unimaginably distant future, it no longer emits any glow. When that happens, what remains will be a black dwarf, a completely cold, dark, and silent body, drifting through space without releasing energy. No light, no heat, no memory of what was once the sun. This is the ultimate fate of medium-sized stars like ours, to die slowly, fading until they become invisible. In that distant future, the universe will be another place. Galaxies will have drifted so far apart that the sky will be almost empty. No planets will remain, no trace of life will survive. The white dwarf will be just a cosmic rock floating in nothingness, a mute witness to a luminous past. What was once the sun, the center of heat and life in the solar system, will become a fossilized memory within the fabric of space-time. Yet every particle that once composed it will continue to exist, scattered, waiting for a new cycle of creation. In the cosmos, nothing is lost. It merely changes form, silently. The birth of the white dwarf is therefore more than the end of a star. It is the return of matter to eternity. It is the moment when light becomes memory and fire becomes silence. The sun will continue to live for trillions of years in this compact, dense form, radiating what remains of its heat. And when finally even that energy fades, the universe will still hold the trace of its existence, not as a shining star, but as an invisible, motionless, eternal point. The sun has gone out. What was once the luminous center of the solar system has become a small, cold, and silent white dwarf, lost in space. The light that sustained life no longer exists. The heat that shaped the seasons, the winds, and the tides has vanished forever. Earth, or what remains of it, drifts around a dark body, without light, without warmth, without purpose. The solar system, now reduced to fragments and debris, has plunged into absolute darkness. It is the era of shadows, the moment when the universe forgets the memory of the sun. In the space that was once bathed in golden light, absolute cold now reigns. Temperatures fall to the very limits of physical possibility. The radiation that was once intense and vital dissolves into silence. No wind blows, no sound travels. All that remains is the echo of the past, lost among the stars. Earth, frozen, is a ruin of stone and iron, covered by an eternal layer of ice. The oceans that once shimmered beneath the blue sky are solidified, transformed into monuments of crystal. The atmosphere is gone, the magnetic field has ceased, and the planet is now an immobile shadow, turning aimlessly around an extinguished heart. The giant planets, once the distant guardians of the solar system, continue their slow orbits, wrapped in a light so faint that even their shadows no longer exist. Jupiter and Saturn have become spheres of ice and frozen gas, surrounded by invisible rings of dust. Their moons, once active and alive, are now coated with layers of ice, hard as metal. Uranus and Neptune, at the system's outer borders, remain silent, blue ghosts adrift in an ocean of darkness. No motion, no spark, no color, only cold and emptiness. At the center of it all, the white dwarf cools slowly. Its light fades until even the most sensitive instruments could no longer detect it. Over the course of trillions of years, it transforms into a black dwarf, a completely frozen, lightless body, invisible even to time itself. It is the sun's final corpse, a cosmic stone wandering without energy. No observer will exist to see it. No trace of human civilization will remain to remember it. The universe, indifferent, will continue its infinite expansion, carrying away what was once the home of all known life. The era of shadows is also the era of silence. Without the sun, there is no more dawn, no more motion. Geological forces have ceased, tectonic plates have fallen asleep, and the planet has become a motionless sculpture. Rivers are frozen, continents buried beneath a uniform layer of darkness. The Earth's core energy is gone, and even the planet's magnetism has died. No trace of heat rises from the ground. What remains of Earth is a stellar fossil, spinning slowly around a point that no longer exists. Yet paradoxically, the end of the sun is not the end of matter. The particles that once composed it still exist, scattered through space. Every atom, every fragment, every molecule still has a role in the fabric of the cosmos. What was once light is now part of the interstellar dust. Somewhere far away, perhaps a new star will be born from this same material. What we call the end is merely a pause in the eternal cycle of transformation. Energy never disappears. It merely changes form, waiting for the right moment to awaken again. A universe without the sun is a place without memory, but not without continuity. The sun's matter mingles with the dust of galaxies, traveling across unimaginable distances until gravity gathers it once more into a new point of light. Thus the sun, even in death, still participates in creation. The absolute silence that now reigns over the solar system is only the pause between one life and another, because in the cosmos, nothing ever truly ends. Even when all fades, there is always the possibility of beginning again. Total darkness is merely the interval before the next star. Nothing in the universe disappears. Everything transforms. When the sun is completely extinguished, its matter, scattered through the depths of space, will continue to travel in silence. Starlit dust, plasma fragments, and loose atoms will drift for trillions of years, blending with the interstellar gas that fills the galaxy. These invisible and dispersed remnants will become the raw material for new molecular clouds, the cradles of future stars. Just as the sun was born from the collapse of an ancient cloud, other stars will rise from the echoes of its death. It is the endless cycle of cosmic creation, the eternal breath of the universe. When gravity gathers this dust once more, the process will begin again. Regions of dense gas will start to collapse, and at the heart of these new clouds, the heat will rise until nuclear fusion ignites again. A new star will flare to life, young and vibrant, illuminating the remnants of the ancient solar system. Around it, particles and debris will merge, forming protoplanetary disks, the molds of new worlds. What once belonged to the Sun, to Earth, to Mars, and to Saturn may recombine into new forms, perhaps even into habitable planets, perhaps into future civilizations that will never know they were born from the ashes of another star. This continuity is the deepest law of the cosmos. No destruction is absolute. When a star dies, it returns to space the elements it once forged, the carbon of living bodies, the iron in blood, the calcium in bones, all were born inside stars. Throughout its life, the sun transformed primordial hydrogen into more complex elements, and in dying, it will release these elements to the universe, enriching it. That is why every generation of stars is richer in matter than the last. The stars of today are the heirs of those that came before. Life exists because stars die. On a larger scale, this cosmic recycling is the engine of galactic evolution. Entire galaxies are reshaped as stars are born and die, releasing both energy and matter. Space, which at first seems empty, is in fact a vast laboratory of creation. The death of a star like the Sun provides the interstellar medium with the fuel for countless new systems. Every fragment of solar dust will be a seed, and somewhere, far away in time and space, that seed will once again become light. Perhaps one day a planet will form from one of those fragments, and on its surface, life will flourish again. It might be a different form, a new kind of consciousness, a being that gazes at the sky and contemplates the light of its own star, unaware that trillions of years ago, that light was the glow of another sun. This is the poetry of the cosmos. Everything that exists is the inheritance of something that has already died. Stars do not vanish, they transform into others. The death of one is the birth of many. The end of the sun is merely a passage, a surrender to the infinite continuity of creation. The cosmic cycle is the true meaning of eternity, not individual immortality, but the persistence of matter, energy, and motion. What we call an end is merely a curve in a road that never ends. When the sun fades and the solar system disappears, the universe will not mourn it. It will simply absorb it, reorganize it, and return its essence in a new form. Thus the sun will live forever, not as a star but as part of everything. In every atom floating through space, there will be a trace of its ancient light. And when, in a distant future, new stars ignite, their glow will also be the glow of the reborn sun. The cosmos renews itself with every death. Creation and destruction are not opposites. They are the same motion seen from different sides. And within this endless cycle, the universe finds its harmony, an infinite dance between the birth and the fading of stars. The sun's final breath will be the first whisper of a new world. Even the universe has a destiny. Like the sun, the stars, and the galaxies, the cosmos itself is an entity that is born, evolves, and dies. From the very instant time began, when matter and energy first separated, everything has been moving in one direction, toward weakening. The expansion of space, which began with the birth of the universe, continues to accelerate. Galaxies drift away from one another at ever-increasing speeds. What today is a web of light and energy will one day become only darkness and silence. It is the inevitable future. The universe will fade slowly until only absolute cold remains. In billions upon trillions of years, all stars will have burned their fuel. White dwarfs will cool and become black dwarfs. Neutron stars, already without light, will continue to drift through the void, occasionally colliding in explosions that produce the last flashes of energy in the cosmos. Black holes will dominate galaxies, devouring everything near them, but even they will have an end. The radiation emitted by these bodies, described by Stephen Hawking, will cause them to evaporate slowly. One by one, they will vanish, leaving behind only scattered particles and the faint vibration of empty space. When the last black hole fades, the universe will enter its final phase. This state is known as thermal death. It is the point at which all the energy in the cosmos becomes evenly distributed. No temperature difference will exist, and therefore, no movement will be possible. Time, which depends on change and transformation, will lose its meaning. Space will become a dark, motionless ocean, filled with subatomic particles drifting without direction. No sound, no light, no memory. It will be the deepest silence of existence, the moment when the universe, exhausted, rests forever. Yet even in that absolute end, matter will still persist in some form. Photons, the particles of light that traveled for trillions of years, will continue to cross the void. The remaining radiation, though nearly imperceptible, will be the last trace of the cosmos's original heat. This echo will be the distant memory of everything that once existed, of stars, galaxies, worlds, and civilizations that arose and vanished across countless eras. Every particle of energy that once shone will still be there, scattered through infinity, a faint murmur of what was once creation. There is also the possibility that the universe might begin again. Some cosmologists suggest that after expanding to its limit, space might contract once more, triggering a new collapse and a new birth, an infinite cycle of cosmic rebirth. Others believe that expansion will never cease, and that space will continue stretching until all galaxies are so far apart that no star can be seen from any point in the cosmos. In that scenario, the universe will become an eternal frozen desert, where solitude is the only form of existence. Regardless of the final outcome, the path remains the same, the gradual decline of energy. Life, light, and heat are only temporary manifestations of matter's organization. Ultimately, everything tends toward equilibrium, an equilibrium that is the same as stillness. The universe, which began in an instant of infinite energy, will end in a state of absolute calm. That will be the final twilight of all that exists. No star will shine, no galaxy will glow. Space will become indistinguishable, an infinite expanse without sound, without color, and without motion. And yet, there is something profoundly beautiful in this end, because in a way, the universe will not disappear. It will only transform once more. What we call thermal death may be only the rest between cycles. Perhaps somewhere, in some dimension we do not yet comprehend, new laws will emerge, and matter will reorganize into another form of existence. The cosmos, after all, is made of paradoxes. It was born from nothing, and perhaps it will return to nothing only to begin again. The end of everything is not emptiness. It is the interval before the next awakening. The final destiny of the cosmos is the greatest mystery of science, and also its greatest revelation. Nothing is eternal, and even infinity has an end. The light we see today is the trace of a past long gone, and the darkness to come is merely the natural continuation of that story. When all things fade, the universe will be at peace, and in that absolute silence, the memory of the sun, the small star that once shone in an ordinary galaxy, will still exist, invisible, dissolved in eternity. Everything that had a beginning will one day find its end. The sun, the star that sustained life, illuminated oceans, inspired civilizations, and shaped Earth's destiny, will cease to shine. But the end of the sun is not a tragedy. It is simply the conclusion of a cosmic cycle that repeats itself in every corner of the universe. Just as the leaves fall to nourish the soil that will give birth to new trees, the sun will also die, so that new stars may be born. Its light, which has traveled billions of kilometers to reach every living being, will continue its journey through space, crossing time and spreading as a memory. Nothing in the cosmos is wasted. Everything returns, everything transforms, everything begins again. When the last photon emitted by the sun crosses the void, it will carry with it the memory of humanity. The light that once reflected on mountains, that shimmered over cities, and that warmed the oceans will continue to travel for trillions of years, bearing witness to the life that once existed here. Even if no one sees it, that light will remain, an eternal letter written in the language of the cosmos. Somewhere far away, perhaps in another time, it will still be traveling, silent, weightless, and pure. The sun will cease to exist, but its presence will live on in everything it once illuminated. The death of the sun is also a mirror of what we are. Just like it, we too live in cycles. Birth, growth, maturity, and disappearance are all parts of the same universal order. The difference lies only in scale. While human life lasts mere decades, the sun's life spans billions of years. Yet both follow the same principle: to transform energy, to create, and one day, to return to silence. The nature of the cosmos is the same as that of life. Nothing is lost, it only changes form. Every atom in our bodies once belonged to ancient stars, and one day it will belong to others. The sun lives within us, and we live within it. The end of the sun will mark the end of light as we know it, but not the end of beauty, because the true brilliance of the universe does not lie in the stars, but in the fact that everything is part of something greater. The death of a star is the birth of new possibilities. Darkness is not absence, but an interval. When the sun disappears, it will have fulfilled the noblest role a star can have: to have given life, to have been the heart of a blue world that dreamed, thought, and looked up at the sky, to have transformed dust into consciousness, to have ignited eyes that once looked at it with gratitude. And when the final night falls over the solar system, the silence will not be empty. It will be the rest of a story that began with fire and ended in stillness. The universe will not mourn the sun, because everything it was remains scattered in every fragment of matter, in every particle of energy, in every trace of light still traveling through space. The sun will not truly die. It will only change form, dissolving back into the same fabric from which it was born, and so the cosmos will continue to exist, renewing and rebirthing itself endlessly. In the end, the sun's final breath will not be the sound of death, but the echo of eternity. The light will fade, but the energy will remain. The heat will cease, but transformation will go on. The universe does not know the concept of an end, only of continuity. And as long as there is matter in motion, the dream of creation will endure. The sun, which was once born from darkness, will return to it. But within that darkness, something new will begin. For the story of the cosmos is infinite, and every fading star is merely the prelude to another that will rise. And you, listening to this story beneath the rain, remember, the same light that once burned in the sun now shines within you. We are made of the same matter, the same cosmic dust, the same dream that moves the stars. The universe is the mirror of life, and life, the reflection of the universe. The sun does not go out, it merely changes form. And we, made of its light, will never cease to exist. We are the continuation of its glow. We are the final breath of light. The universe is made of the same matter that forms you. And when the stars die, part of them lives on within us. We are fragments of ancient light traveling through time, reminding the cosmos that nothing truly ends. It only changes form. And before sleep takes you, tell me in the comments, where are you listening to this story from tonight? In what part of the world are this voice and this rain keeping you company now? Leave your like, subscribe to the channel Dormindo com Ciencia. May the light of the stars keep guiding you until the next video.